Next topic we have to discuss is joins. So we'll see joins. What is the purpose of using joins? How many types of joins we have, that we will discuss. See, joins concept is most important as point of interview and as well as for working as well. See, what is the main purpose of using joins? By using joins, we are going to be retrieve the data from more than one table. Till now, in the previous sessions, whatever the examples we have discussed, those examples are related to accessing the data from a single table. Accessing the data from a single table. That is uh, joins. Sorry, that is normally how we can able to access the data. But what is the specialty of joins is by considering more than one table, we are going to be access the data. I mean to say like accessing the data from more than one table. For that purpose, we are going to be use the joins. Accessing the data from more than one table. See, before having this joins concept, now we have discussed accessing the data from a single table. All the examples for what we have discussed till now are accessing the data from single table. Now we are going to be access the data from more than one table. So if we want to access the data from more than one table, definitely we need to use the joins. Without using joins, we cannot able to retrieve the data from more than one table. సో ఇప్పటి వరకు మనం డిస్కస్ చేసింది సింగిల్ టేబుల్ నుంచి డేటా ఎలా రిట్రీవ్ చేయడం, మనకు కావాల్సిన రోస్, మనకు కావాల్సిన కాలమ్స్, మనకు కావాల్సిన డేటా ఫ్రమ్ ఏ సింగిల్ టేబుల్ రిట్రీవ్ చేసాం. సో ఇప్పుడు మోర్ దాన్ వన్ టేబుల్ నుంచి రిట్రీవ్ చేయాలంటే దెన్ డెఫినెట్లీ వీ నీడ్ దిస్ కాన్సెప్ట్ కాల్డ్ జాయిన్స్. See, joins used to combine columns from two or more tables based on values of the related columns. Based on the values of related columns. See, we have different types of joins. Different types of joins. First one, inner join, and we have left join, right join, full outer join, and then cross join. Cross join. Now, see, if you want to apply the joins, first identifying the foreign key is important. See, what is primary key, what is foreign key, that identification is most important for us if we want to apply the joins. See, primary key, we know that already in a particular table, if we have unique identification column, among all the unique identification column, one column will be considered as primary key. If suppose if I am considering the employee details table, employee ID is the employee ID is the primary key, where it will be helpful for us accessing the data related to that particular employee. Related to that particular employee. Unique identification. There will be no employee without having employee ID even once if they join into the organization. In the same way, if I am considering one more table called as department. For department, each department there will be unique ID. Each department there will be unique ID. See, first table if I am considering the department, department ID, department name, employee, this so and so data will be there. And if I am considering the employee table, employee id, department id, or employee id, employee name, department id, and so on. See, in the first table, if I am considering the department, their department id is there, which will be acting as primary key in that particular table. And in the second table, employee id column will be considered as primary key. And in this table, if we have department id, so then that will be considered as foreign key, because there is some relationship with the data what we have in the primary key of department, that is department id, to the column what we have as a department id in the employee table. And the data what we need to have in the department id of the employee table should be as it is same as what we have with the primary key of department table. సో ఇప్పుడు నేను ఒక డిపార్ట్మెంట్ టేబుల్ తీసుకుంటే డిపార్ట్మెంట్ ఐడి, డిపార్ట్మెంట్ నేమ్, ఇలా కొన్ని కాలమ్స్ ఉన్నాయనుకోండి. డిపార్ట్మెంట్ ఐడి విల్ బి కన్సిడర్డ్ యాజ్ యూనిక్ ఐడెంటిఫికేషన్ కాలమ్ అక్కడ. తర్వాత ఎంప్లాయీ ఐడి తీసుకుంటే ఎంప్లాయీ టేబుల్ తీసుకుంటే ఎంప్లాయీ ఐడి, ఎంప్లాయీ నేమ్, డిపార్ట్మెంట్ ఐడి, సో కాలమ్స్ వస్తాయి అనుకోండి. ఎంప్లాయీ ఐడి ఈజ్ ద యూనిక్ ఐడెంటిఫికేషన్ కాలమ్ టు ద ఎంప్లాయీ టేబుల్. కానీ ఇక్కడ డిపార్ట్మెంట్ ఐడి అనేది ఇంకొక కాలం ఉంది. సో ఇందులో ఏ డేటా ఉంటుందంటే డిపార్ట్మెంట్ టేబుల్లో ఉన్న డిపార్ట్మెంట్ ఐడి, ఆ పర్టికులర్ డేటా మాత్రమే మనకు అవైలబుల్ వస్తుంది. సో అలాంటప్పుడు డిపార్ట్మెంట్ ఐడి వచ్చేసి ఎంప్లాయీ టేబుల్లో మనకు ఫారెన్ కీగా తీసుకుంటుంది. సో డిపార్ట్మెంట్ ఐడి ఇన్ ద డిపార్ట్మెంట్ టేబుల్ విల్ బి కన్సిడర్డ్ as ప్రైమరీ కీ. ఎంప్లాయీ టేబుల్లో డిపార్ట్మెంట్ ఐడి వచ్చేసి ఫారిన్ కీ. ఈ ఫారిన్ కీ ఐడెంటిఫై చేస్తేనే then we can able to say that there is a relationship among those two tables and we can able to apply on that. See, how we can able to relate the tables. So here we can represent related columns are typically the primary key column of the first table and foreign key column of the second table. Foreign key column of the second table. Based on that, we can able to get this. See, if we want to give these examples, we need two tables. First, let me create those tables in our database. Let me take the customers table and as well as orders table. Customers table and as well as orders table. Connect. So first, I would like to create uh, the customer table. Create table, and the table name is customers. Table name is customers. Then I would like to give customer ID integer, primary key, customer name, care of 35 size. I can use varchar also if we are considering the size. Let me consider phone number. Like to take int 11, or we take directly 11 also fine, or take some size 20. And then we'll be having location or address varchar of size 35. So here also I'd like to take as varchar. Here it is not like in the name will be having in the name will be having numericals, but here my concern is like the size. The concern is like size. So if I'm giving char of 35, that much space it is going to be placed as it is. So just to avoid that only I'm taking this. So now customers table is created. Now the customers table is created. So if I would like to see the of the customers table, ESC customers. So let me see what are the tables we have. Sorry, what are the columns we have in this particular table? See, as we have mentioned, customer ID is a primary key. It is going to be allow only unique identification columns. Unique identification, it is going to be allow only unique identification values. No duplicates will be there. No duplicates will be there, and no null values. So because of that, if you see null question mark column as not null here. For rest of all, it is not represented anything. It means by default we can able to place some null values as well. So for the primary key column, we are not supposed to give any duplicates, and we are not supposed to use any null values are there. So that is customers table. So I have created one customers table. So now I would like to create one more table that is considered as orders, where we'll be having order ID. So let me consider this data type of this order ID is in. So what we'll be having in the orders table, order ID, uh, like customer ID, and then order date. Let me consider these are the columns we have. And here order ID will be considered as primary key. Orders table is created. If I want to see this orders orders table is created. Now if we observe these two, like here customer ID we have, for this particular table, customer ID is the, I mean, for customers table, customer ID is the unique identification column, that is a primary key for that particular customers column. And we when we comes to this orders uh, table, order ID is the column primary key, and customer ID is the column we have as a foreign key. So there is a relationship between the customer ID column what we have in the customers table and customer ID column what we have in orders table. ఇక్కడ ఆర్డర్స్ కస్టమర్స్ టేబుల్లో కస్టమర్ ఐడి అనేది యూనిక్ ఐడెంటిఫికేషన్ కాలం అయితే దట్ ఈస్ విల్ బి కన్సిడర్డ్ యాజ్ ప్రైమరీ కీ. మళ్ళీ ఇందులో ఆర్డర్స్ టేబుల్లో ఆర్డర్ ఐడి అనేది ప్రైమరీ కీ, కస్టమర్ ఐడి ఈస్ ద ఫారెన్ కీ. సో ఇక్కడ ఈ కస్టమర్ ఐడిలో కస్టమర్స్ టేబుల్లో ఏదైతే మనకు డేటా అవైలబుల్ ఉందో, సో సేమ్ డేటా ఇక్కడ అవైలబుల్ ఉండాలి. సో ఇట్ షుడ్ బి దేర్ ఇన్ కస్టమర్ ఐడి. It is not like more, I mean, apart with the data what we have in the customers, apart with the data what we have in the customers. Okay. Now see, we'll insert some data into that. We'll insert some data into that. First, I'd like to insert into customers. Insert into customers values. I would like to give this as 101, 101, and name is like Sino. Next, phone number. I would like to give 961 something, and location Hyderabad. Insert into customers values. I would like to give the customer ID is 102, and name is Dana. Name is Dana, and I like to give the mobile number is something, some number. Here also is a mobile number. Let me consider location Chennai. Insert into customers values one 103, 103, and name we have Raghu, and mobile number Bangalore. And I would like to take 104 Manoj, and some number will be like so randomly I have taken some data randomly. I mean, so I've taken some data. Insert into customers values. I'll be taking for 105 and Bharat. So here I have entered this data. Now I'll execute all these queries. First, this particular row is inserted. Next, this particular row. This, sorry, your customer. Now select star from customers. So this is the data we have in the customers table. This is the data we have in the customer table. One more thing. In the customer table, we have customer ID, which is primary key, where it should not have duplicates and as well as null values. But in the orders table, order ID is the primary key. There we can have, see in the order ID of orders table, we can have unique, unique values and without null values. But in the customer id we can have duplicate values as well, because that is a foreign key. In the foreign key we can have duplicate values as well. Now we'll insert the data into orders. So as per this orders table, we'll insert the data. Insert into orders values. Order id, let me consider order id is 1 and the customer id is 101. Customer id is 101, and next we need to enter the date. This row is inserted. In a similar way, in a similar way, insert into orders values. Order id will be unique. So that is I have taken as uh, order id is 2, and for the customer 102 I'll be taking this or let me consider order date is today. Some data I'm taking, not exactly what we need to get here. So insert into orders values, so like 3 103. Order id, let me consider 5 3 2020. Order id is 4 and my customer id is 102 again here. uh, that was order on 4 3 2020. Insert into orders values. Order id is 5 and it is 103. Order is 2 3 2023. Insert into orders values 101, and we'll be having 10 to 2023. Just suppose some values. Insert in orders values. Order ID is 7 and customer ID is 104 15. Insert into orders values, and the order ID is, let me consider as 108. Sorry, 8. 105 is this customer ID. Order ID is this one. one more insert into orders valid 10 22 2023. So these all rows will execute. Yeah. So I would like to see the total data what we have in orders. I'd like to see what is the total data we have in the orders. So this is the data. See now select star from customers. Select star from customers. This is the customers data and this is the orders data. See here in the customers table 101, 102, 103, 104, 105 all are unique values. There is no duplicates and there is no null values as well. Whereas coming to these orders will be having order ID is unique 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But if you see customer ID which is considered as a foreign key here where it will be having the values like where it will be having the values like so repetition of values what is there in the customer id of customers table. In the customer id what are the what are the values we have the same will be there. This repetition of the values also we can able to use here. Repetition of values also we can able to get here. See now first we will discuss about the cross join. So just now we have created the tables whatever it is required for us for discussing these particular examples. Now first we'll discuss cross join. Cross join or even we can also call that as a Cartesian product. Cross join or we can also call that as a Cartesian product. In mathematics, if you consider there will be two sets, set A and set B. Set A and set B. Cartesian product of those two sets, how we can able to say Cartesian product of those two sets will be each element of set A is going to be mapped with each and every element of set B. Each element of set A will be matching with each and every element of set B. See, the element of A is going to be mapped with each and every element of set B. In the same way, whereas coming to the cross join, each row of table 1 will be mapping with each and every row of table 2. That is nothing but cross join or Cartesian product. Each row of table 1 will be combining with each and every row of table 2. Each row of table 1 will be combining with each and every row of table 2. That is cross join. Let's suppose, let's suppose after applying cross join in the resultant table, how many rows and columns we have. The number of rows in the resultant column will be number of rows in table 1 multiply with number of rows in table, number of columns, number of columns, number of columns in table 1 plus number of columns in table plus. See, the number of rows we need to get here is number of rows in table 1 into number of rows in table 2. That is total number of rows will be getting after combining after applying the cross chain. If we want to see the number of columns after applying the cross join, that will be number of columns in table 1 plus number of columns in table 2. Let's suppose in the example, is the table 1 has, if table 1 has rows 8, columns 5, and table has rows 5, or let me consider it as a 4, and columns has 6. So number of rows after applying cross chain, number of rows will be 8 into 4. Number of rows will be 8 into 4. So that will be 40 rows will be getting. Sorry, 32 rows. Whereas number of columns, that will be like 5 plus 6, 11 columns. 11 columns will be getting here. So this is the how many rows will be getting. అంటే ఇప్పుడు ఒక టేబుల్లో m rows, సపోజ్ ఒక టేబుల్లో నెంబర్ ఆఫ్ రోస్ వచ్చేసి m ఉంటాయి, నెంబర్ ఆఫ్ రోస్ ఇన్ టేబుల్ 2లో వచ్చేసి n ఉంటాయి. సో దెన్ క్రాస్ చైన్ అప్లై చేసిన తర్వాత టోటల్ ఎన్ని రోస్ వస్తాయి మనకు రిజల్టెంట్ టేబుల్ అంటే m into n. If suppose m columns we have in table 1 and n columns we have in table 2, the total number of columns will be getting in the resultant column will be like uh, number m plus n, number of columns in table 1 plus number of columns in table 2 as well will be getting. See, for applying the cross chain, what will be the syntax in SQL? What will be the syntax in SQL? Select table 1 column, table 2 column 1. Like, so how many columns we require? That many. From table 1 comma table. So that will apply now. I would like to retrieve. I would like to retrieve. Select star from, see, all columns from both the tables and all rows from both the tables. I would like to retrieve. So select star from customers, comma orders. Total, how many rows we got? We got 50 rows. Total, how many rows we have? 50 rows. Each row of customers table is going to be mapped with each and every row of orders table. Each row of customer table is going to be mapped with each and every row of customer table. So now 101 Sinu and the phone number Hyderabad, order ID is 101, this one. And for the same Sinu, the customer row, for all the rows, like 10 rows we have here in the orders table, for all the 10 rows it is going to be combined. So then it will be starts with 102, and for all the 10 rows of 102 will be getting here. For all the 10 rows will be getting here for 102. Like that will be getting. See, I would like to get, see how many rows we have here. In the resultant table, after combining customers and as well as orders, we will be having we will be having uh, 50 rows. So first we'll check how many rows we have in customers. 5 rows, and in orders I think so we have given 10. So because of that, total rows will be getting as total rows will be getting as 50. 5 tens of 50. 5 into 10 will be getting 50. And in the resultant column, how many, sorry, in the resultant of this table, 1, 2, 3, 4, 5, 6, 7 columns we have. In the customers table, we have 4 columns. In the customer table, we have 4 columns. And in the orders table, we'll be having 3 columns. 4 plus 3, 7 columns will be getting. 7 columns will be getting. See, first I would like to get only uh, customer ID, customer name, order ID, order date from customers and orders. See, we are retrieving like this. Customer ID, the same name we have with the same name we have with the customers table and as well as orders table. When we are giving this, which data it is going to be retrieved, there will be ambiguity, there will be confusion. అంటే ఇప్పుడు కస్టమర్ ఐడి అనేది కస్టమర్స్ టేబుల్లో ఉంది, కస్టమర్ ఐడి అనేది ఆర్డర్స్ టేబుల్లో కూడా ఉంది. సో ఆ రెండింటి నుంచి ఏది రిట్రీవ్ చేసుకుంటుంది అంటే, సో హౌ వీ కెన్ ఏబుల్ టు సే, సో కన్ఫ్యూషన్ ఉంటుంది. To avoid that, we'll be giving the reference names that we will discuss. So first let me execute that. Column ambiguously defined. Column ambiguously defined. See, customer ID we have given here. This customer ID, either it has to be retrieved from the customer table or orders table. So అక్కడ మనకి ambiguity వస్తుంది. సో అక్కడ ambiguity వస్తుంది. To avoid that, either I can give the reference for this, I can give the reference of this. For the customers, C is the reference. For orders, O is the reference. Just I have created like that. So you can create any name. So now here C dot customer ID, C dot customer name. So then we are giving like C dot customer ID, C dot customer name. It is going to be access the data from that particular table. The reference table of C is customers. Similar way, there is no ambiguity for the order ID, but still I am writing this. There is no ambiguity for the orders, but still I am writing. That's not a problem. So we are retrieving the data as per our requirement. Now, this is one way, and the other way we have here for getting this is, instead of creating the reference C and O, directly I can use the table names as well. Instead of creating reference, directly I can use the table name as reference. So we'll be getting the same data. 50 rows of data we are accessing. So this is how we are going to be apply the cross join. In the next session, we will be discussing like other joins, like full join, left join, right join, equi join. This all we will discuss. Okay. In this, if you have any doubt, let me know.